This is ISCI 2001, Chapter 17, Earth's Weather. The themes for this lecture include the atmosphere, the composition of the atmosphere, and the structure of the atmosphere, the winds, local wind patterns, and water in the atmosphere, and that includes evaporation and condensation, fog and clouds, and precipitation. The atmosphere is a thin shell of gases that surrounds the solid Earth. The higher you go up, so with an increase in altitude, the thinner it gets. So if you're at sea level versus if you're on top of a mountain, the atmosphere is thinner on top of the mountain. That's also why it's colder and it's harder to breathe and absorb the oxygen because there's less air pressure. 99% of its mass is within 20 miles from the Earth's surface. So relatively speaking, it's not that large. This is some satellite imagery taken, and it shows, you can see the thin blue light that's running just above the Earth's horizon. That's how thick the Earth's atmosphere is. So it's really not that thick in comparison to the size of the Earth. The composition of the atmosphere. Pure air is colorless, odorless, and composed mostly of nitrogen, oxygen, and argon. Nitrogen makes up about 78%, oxygen 21%, and then argon makes up 1%. Nitrogen and oxygen both have cycles that cycle them within the Earth and the atmosphere, and we'll talk about those in just a second. Argon, it does not have a cycle. It's usually released from like radioactive decay, and it's just kind of used as a filler, but we'll also talk about that a little bit more in just a moment. Nitrogen does not readily enter into chemical reactions with rocks, so it's accumulated in the atmosphere. Some of it's removed from the atmosphere by certain bacteria in the soil and by lightning. That bacteria is called nitrogen-fixing bacteria. The nitrogen is needed for the growth of plants, and eventually it'll be returned back to the atmosphere through the decay of plants and animal matter. The nitrogen cycle, it cycles multiple different ways. Let's start on the left-hand side with the blue-green algae in the world's seas and oceans. It can take the nitrogen in. When that blue-green algae is eaten, it's stored inside the plant proteins and the animal proteins. When those dead organisms start decaying, it's released. Also, when they defecate, it's released in their feces. And then most of that is lost to the marine sediment. Now, if it's taken up by nitrogen-fixing bacteria in the soil, that nitrogen-fixating bacteria is located in the root nodules of plants that produce like beans and peas. When that plant takes it up and uses it, then it's then released back into the soil as soil nitrate. When that plant starts breaking down, the denitrifying bacteria in the boggy soil will release it back into the atmosphere. When lightning strikes the soil, it also produces soil nitrate. The plants will then take it up, and then the denitrifying bacteria in the boggy soil will release it back to the atmosphere, or it can be taken up by the plant roots, like trees and such. When the trees take it up, and it's stored inside the trees in the plant proteins, but it's also stored in animal proteins when the animal eats it. When the animal dies or when it defecates, it releases that nitrogen as ammonium salts. Then the nitrifying bacteria puts it back into soil nitrate, and then it once again goes into the denitrifying bacteria in the boggy soil that releases it to the atmosphere. The other way that nitrogen is released into the atmosphere is by volcanic action. Oxygen is removed from the atmosphere by living organisms and by chemical weathering of rocks. It is released by green plants as a result of photosynthesis, and the amount released by the plants balances the amount removed by the organisms and by weathering. Photosynthesis, basically what you're seeing is up on the upper right hand side, you see the sunlight entering into the leaf. The chemical reaction occurs. It has to have sunlight, it's got to have carbon dioxide, and it also has to have water to produce the sugars and the oxygen. So oxygen is actually a byproduct or a waste product for the plant. The plant cannot use oxygen, but you can see on the bottom right hand side of the picture that we do. We use the oxygen, we release carbon dioxide. The plant once again takes up water, the sunlight hits the leaf, it creates chemical reaction in the chloroplast and the chlorophyll of the leaf. Sugars are released, and once again oxygen is released. So it's just one big cycle. Argon is inert, which means it's not reactive, and it does not enter into any chemical reactions or cycles. It is produced as a product of radioactive decay, and once it's released, it remains in the atmosphere as an inactive filler. The lowest part of the atmosphere is warmer, and the temperature decreases with increasing altitude. On the picture on the right, you can see Earth at the bottom, and then troposphere runs about 14 kilometers up, and then you hit the tropopause before you go into the stratosphere. Then it's the mesosphere, then it's the ionosphere. The troposphere is where all weather occurs. So all of your clouds, all of your storms, everything is going to be no higher than the troposphere. The stratosphere is where, when you fly in an airplane, this is the layer of the atmosphere where airplanes fly. They fly above the weather. The stratosphere is also where the ozone layer is maintained. And then just above the ozone layers, one is still a small piece of the stratosphere, and then you hit the mesosphere. As you go up through these layers, the temperatures are increasing and decreasing. And the warmest part is going to be the troposphere. The coldest spot is going to be the ionosphere. This is another reason why when you're on a mountain, you know, it's colder on top of the mountain, even though you would think that it would be warmer because you're closer to the sun. But because the atmosphere is so thin, it cannot hold the heat because the air pressure is not great enough. So that's one of the reasons why the higher up you go, the colder it gets. This is an exaggerated picture of the things that you see. So you've got the troposphere, stratosphere, mesosphere, thermosphere. It shows a picture of a hot air balloon in an airplane. Of course, the hot air balloon is going to stay in the troposphere. Airplane is troposphere and stratosphere. Mesosphere is where most of your meteorites are going to burn up. So when you have a meteor shower, that's where they burn up in that layer. Typically, if they don't burn up in the mesosphere, then they do hit the Earth. Then you have your thermosphere, which is where your satellites, and also the aurora, the northern lights, is located in the thermosphere. The winds. The troposphere is heated from the bottom up as the surface of the Earth absorbs sunlight. As a local region of air becomes heated, the air expands, and that reduces its density. This less dense air is pushed upward by nearby cooler and more dense air. A horizontal movement of air is called wind, and the direction of a wind is defined as the direction from which it blows. So a southeastern wind, a northeastern wind, whichever direction it's blowing from is what the wind is called. Local wind patterns. There are two factors that help determine local wind patterns. The first is the relationship between air temperature and air density. The cool air has a greater density than warm air because a mass of warming air expands and a mass of cooling air contracts. The relationship between air pressure and the movement of air, basically whenever you have your different air pressures, high pressure and low pressure, and that movement of air, that's what creates storms. When a cool front hits a warm front, there's so much contracting from the cooling air and expansion from the warming air that it just basically can create a huge storm. Water exists in all three states. Liquid, which is temperature above 0 degrees Celsius, solid in the form of ice, snow, or hail below 0 degrees Celsius, and then gas, which is water vapor. Over 98% of all liquid on Earth exists in the liquid state, and only a small variable amount of water vapor is in the atmosphere. You've got liquid water up top, you have your ice down bottom, and then your water vapor to the right, and clouds are formed from water vapor. Water in the atmosphere. The small amount of water vapor contributes to the greenhouse effect, which makes the planet warmer. It also serves as one of the principal agents in the weathering and erosion of land, which creates soils and sculptures the landscape. And then it also maintains life for all organisms, because we all know that we can go longer without food than water. We have to have water, or our bodies will shut down. It will not be able to maintain homeostasis. Evaporation and condensation. Water tends to undergo a liquid to gas or a gas to liquid change. Evaporation is when more molecules are leaving a liquid state than are returning. Condensation is when more molecules are returning to the liquid state than are leaving. And then saturated air is an equilibrium condition between evaporation and condensation, which basically means that it's stable. Air will remain saturated as long as the temperature remains constant and the process of evaporation and condensation remain balanced. Once one of those variables changes, though, if the temperature changes even just a little bit, then that balance is going to be disrupted, and that's when you're going to have usually, either evaporation or condensation will happen, or some type of weather will happen, such as rain. Fog and clouds. Fogs and clouds are both accumulations of tiny droplets of water that have been condensed from the air. These water droplets are very small, and a very slight upward movement of the air will keep them from falling. If they do fall, however, they usually evaporate. On the left, you have a picture of fog. On the right, you have a picture of clouds. And you can, basically all fog is a lowered cloud. It's a cloud that is at the Earth's surface. So when you are walking through fog, you're walking through a cloud. A fog forms because air containing water vapor and condensation has been cooled. Clouds are tiny droplets of water that have been condensed from the air and form when a mass of air above the surface is cooled. And we have different types of clouds. You have the cirrus, which look kind of curly in the sky. You have cumulus, which look piled up or like big balls of cotton. And then stratus are spread out. On the bottom right, you can see cumulonimbus. Anytime you see the word nimbus, nimbus means weather forming, like rain is typically going to fall from that, or snow, any type of precipitation. Starting at the bottom left, you've got stratus, and then beside the stratus you have cumulus. And you can see the difference in the two cloud shapes. Stratus is more spread out. That's going to be like your more your overcast, just dreary looking day. Those are that don't produce any type of weather. That's going to be your stratus clouds. They're very low-lying clouds. Your cumulus clouds will form into cumulonimbus eventually. We'll talk about that more in just a moment. Above the stratus, you have nimbostratus, and that's typically like your snow-forming clouds. Because remember, anytime you see nimbo or nimbus, that's going to be a weather-forming cloud. Stratocumulus is a mixture between stratus and cumulus. They still look kind of fluffy, but they're spread out. Altostratus is when it's going from a stratus cloud, and the next step up will be a cumulus. The altocumulus is going to be, they're still kind of fluffy, but they're more, there's more spaces in between them. It's not just a solid sheet. Then when you get up to the cirro or the cirrus, these are going to be clouds that are made of ice crystals. They're so high up, it's so cold that it's no longer water vapor, it is actual crystals. And that's what gives them kind of a wispy look. So you have your cirrostratus, your cirrocumulus, and then your regular cirrus. Your cirrus are the hardest ones to see. They're very thin. They're very, very high up. Now, look back over at the cumulonimbus. You can see that it rises, okay? What has actually happened is the cumulonimbus cloud was actually higher up, and even though it looks like it's rising, it's doing the opposite. It's actually dropping, okay? At the top, that's where it had reached its saturation point, and then that cumulus cloud dropped because of all of the water vapor. As it drops and gets closer to the earth and hits that warmer air, remember, once again, that cool air going from cool to warm, it's going to make this state of equilibrium. It's going to throw it off, okay? And so that's what's going to release the rain or the water from the clouds. You have three classifications of clouds. You have your low-lying clouds, middle clouds, and high clouds. Your low is going to be cumulus and stratus. Cumulonimbus is going to encompass all three, okay? Your middle clouds are going to be your altocumulus and your altostratus, and then your high clouds are going to be cirrus, cirrocumulus, and your cirrostratus. Precipitation. Water that returns to the surface of the earth in either a liquid or a solid form is called precipitation. The liquid would be rain, the solid would be snow, hail. A mixture of the liquid and the solid would be sleet. Precipitation seems to form in clouds by one of two processes. Either it's the coalescence of cloud droplets, which means all the droplets in the clouds move together, or it could be from the growth of ice crystals, and when those ice crystals get too heavy, they fall. Here we have the water cycle. You can see the uptake, which is on the left-hand side from the ocean, the soil, and the lake. That water evaporates from all three of those. It can also evaporate from streams and rivers. It evaporates, then it condensates into the clouds. Once it's reached its saturation point, then precipitation occurs. Once again, look and see how that cloud has dropped. Once the precipitation goes, you've got surface runoff. It goes back into the lakes, back into the river, back into the soil. It also goes through the soil and into the water table or the groundwater. And then from there, once again, it's going to evaporate, condensate, precipitate. Evaporate, condensate, precipitate. What we were able to do with this GPS standard is, even though it says recognize and describe different biomes and how they're affected by the weather, plant, and animal activity and the geologic processes, even though we didn't talk about the specific biomes, we did talk about how the earth specifically is affected by weather, plant and animal activity, such as the different cycles like the nitrogen cycle and the oxygen, how like photosynthesis takes that carbon dioxide, switches it into oxygen, and then the geologic processes, how the different types of weather like rain and such will actually contribute to the weathering process of rocks and soil. So we did talk about all of the three different types, but instead of doing it just for specific biomes, we did it as the earth as a whole. Don't forget to go to Georgia View and do your weekly quiz. Also, don't forget to participate in the discussion. We do have a quiz at a test at our next meeting, and I will see you then. Have a great day.